Okay, Trig. So we are finished kind of graphing sine and cosine, and we're going to move into tangent, cotangent, secant, and cosecant. So the thing to remember with tangent, cotangent, secant, and cosecant is unlike sine and cosine, these four trig functions have places where they are undefined, okay, where we have vertical asymptotes. Let's think about our unit circle quizzes that we've been taking. The tangent of every odd pi over 2 is undefined, correct? Let me think of your unit circle. So at every odd pi over 2, 1 pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, negative 3 pi over 2, we're going to have vertical asymptotes. Oh, that wasn't very good. Sorry. Okay, so go ahead and put those vertical asymptotes in your notes at every odd pi over 2. Okay, so it's going to be broken up like that. Now, at every pi, 0 pi, 1 pi, 2 pi, 3 pi, etc., the tangent is 0. So I know at 0, the tangent of 0 is 0, the tangent of pi is 0, the tangent of 2 pi is 0, negative pi is 0, etc. I also know that the tangent of pi over 4 is 1. Okay, if we're gonna, I'll just go like so, 2, 4. Okay, the tangent of pi over 4 is 1. The tangent of negative pi over 4, see, negative 45 degrees, that's down in the fourth quadrant. That's going to be negative 1. Okay, we end up getting, okay, if I'm going to let my asymptotes guide me here, I always say that tangent, and I know this is maybe bad, but I always say that tangent reminds me of x cubed. Now I feel like that's just what it looks like to me. And it just keeps repeating that pattern between all its vertical asymptotes. Okay, that's what tangent looks like. Now cotangent is going to be undefined wherever tangent is 0, right? So its vertical asymptotes are at the opposite spots. Its vertical asymptotes are at 0 and pi, right? That's where we're going to have our vertical asymptotes. I guess I was graphing these on the same axis, which is a little awkward, but its asymptotes are at 0 and pi and 2 pi, because wherever tangent is 0, cotangent is undefined because cotangent is the reciprocal. I'm going to graph it here on Desmos instead. Okay, guys? Let's pull that up here. And I'm going to type in y equals cotangent of x. And if you'll notice, it's not showing me the vertical asymptotes, but I can see I'm right here at negative pi, at 0, at pi. Okay, and do you notice that instead of looking like x cubed and an increasing function, cotangent is decreasing between the asymptotes? Okay, because again, the cotangent of pi over 4 is 1, right? The cotangent of negative pi over 4 is negative 1. But remember, the asymptotes are in between here. The cotangent of 3 pi over 4, 3 pi over 4 is in the second quadrant. That's negative 1. Okay, so that's where those come from. So the vertical asymptotes, I know we can't see them here. I'll maybe type one in. X equals pi is a vertical asymptote there. Okay, x equals 0 is another vertical asymptote. Do you see it? Okay, so the main, it repeats every pi. 2 pi isn't the period for tangent and cotangent. It's just pi. Okay, this is what gets repeated, this decreasing curve that goes through 0 at every odd pi over 2. Okay, the period of cotangent is pi, just like the period of tangent is pi. Okay, it goes, our first one sort of goes from negative pi over 2 to pi over 2, and it's an increasing function. And then from pi over 2 to 3 pi over 2, and it's an increasing function. Okay, I'll take these green. I started to graph cotangent at the same time, but I don't really want to do that. Okay, so tangent and cotangent, that's what they look like. The graph of tangent is discontinuous at values of x that are every odd pi over 2. Those are vertical asymptotes. The x-intercepts are in the form of any n pi. Its period is pi. There is no amplitude because it goes up and down forever. The graph is symmetric with respect to the origin, so it's an odd function, okay? So let's look back at that again and make sure that makes sense, all right? So we said the asymptotes are at every odd pi over 2. The x-intercepts are at every n pi. There's no amplitude. The period is pi, and it's an odd function. The tangent of pi over 4 is the opposite of what we would get for the tangent of negative pi over 4. Okay, and then we have cotangent, which was different in the x-intercepts, and the asymptotes are flipped. This time the asymptotes are all the n pi's. Those are the vertical asymptotes. And the x-intercepts are all the odd pi over 2's. Period still pi. The graph has no amplitude. And this time I'm an even function. The graph is symmetric. It's the same. The graph is symmetric with respect to the origin again. The function is odd. Tangent is odd. Cotangent is odd. They're both odd functions, okay? That's cotangent. All right, so let's think about the graph of y equals the tangent of x over 2. What I want you to see is think about how we graph sine and cosine. We let x over 2 equal the 5 key points. Well, for tangent, the key points are really those asymptotes, right? I want to know when I'm taking the tangent of an odd pi over 2. So when is x over 2 going to be pi over 2? Because then I know that's going to be undefined. When is x over 2 going to be negative pi over 2? There's another undefined. Those are kind of my first two undefineds. So to get x by itself, I would multiply by 2. So that gives me x equals pi. So when I put pi in for x, I'm taking the tangent of pi over 2, which I know is undefined. When I put, I'll multiply by 2 here, and I get negative pi. Negative pi gives me undefined. Pi gives me undefined. Okay? 0 still gives me 0. Pi over 2. Pi over 2 is the same as, taking the tangent of pi over 2 over 2. That's the tangent of pi over 4, which is 1. And negative pi over 2 gives me negative 1. So you can see that the tangent of x over 2 kind of widen this out, right? Just like when I multiply by a half, like I take the y equals a half x squared. It makes it a wider graph. Now my period is not pi, it's 2 pi, right? I went from negative pi to pi. What we can do is similar to what we do with sine and cosine. The period, we'll take the regular period of tangent, which is pi, and divide it by a half in this case, because really this is the same as saying the tangent of a half x. Okay, so if I take pi divided by a half, that's 2 pi. So that told me that the period was going to be 2 pi. Okay, so it's very similar to how we graphed. It's a little bit easier, I think, to graph tangent because you're just looking for the asymptotes. And then you're looking for the 0, and then you know what it looks like in between, right? It's just an x cubed graph, kind of, is what I call it. Okay, now, to graph secant and cosecant, we need to graph sine, okay, and cosine. So I'm gonna graph sine with a dotted line, okay? What is it? 0, pi over 2, pi, 3 pi over 2, 2 pi, Okay. This is what sine usually looks like. Well, it does look like. Not usually. Okay. I'm just dotting it in here. Okay. What I want you to realize is whenever sine equals 0, cosecant is undefined. So I want to graph the cosecant of x by graphing the sine of x. And everywhere that sine is 0, which is all the n pi's. Okay, for cosecant, those are going to be asymptotes. I'm going to have asymptotes at every pi, including 0 pi, which is 0. Okay, and then I'm flipping all these. I'm taking the reciprocal of all these. Cosecant is the reciprocal of sine. So the reciprocal of 1 is 1. But the reciprocal of that other stuff, I end up flipping this little parabola upside down. Same with this one. Same with this one. These are going upside down. This one's going up. Okay? So when I think of y equals cosecant, the period is 2 pi. And it really goes from 0 to 2 pi here. The first one is a parabola opening up at pi over 2, 1, and then a parabola opening down at 3 pi over 2, negative 1, with asymptotes at every pi. Again, let's look at it on Desmos. I hope you're doing that off and on. It's such a great tool. There's y equals cosecant x. Okay, and that looked nicer than what I did. The vertical asymptotes are at x equals negative pi. I'm just going to put some in here so we see them. X equals 0, all the pi's. X equal pi. Okay, so I'm just, putting them there so you can see them a little bit better. But this is cosecant, guys. It's, can you picture sine underneath it? Okay, I always draw sine. And then I know exactly where to put my asymptotes and how to flip it. Okay, because I just flip the little parabolas underneath them. Okay. Cosecant, then, the domain is all x's except if x is in n pi, because then that's going to be a vertical asymptote. I can't flip 0. Okay, so the range, notice how the range, instead of going from negative 1 to 1 like sine is, the range is the opposite of that. It goes from negative infinity to negative 1 in union with 1 to infinity. Okay, think about it. There's no blue part that's in here. My y coordinates are 1 and bigger. Or my y coordinates are negative 1 and smaller. But there aren't any y coordinates in between negative 1 and 1 where sine usually is. Okay, and here's just some of we don't really need those too much, but if you want to graph them, you can. I just flip the parabola. Okay, and then, so here's the cosecant graph, and this is what it kind of looks like if you do it on the graphing calculator. Okay, they're just parabolas flipping back and forth. Okay, and then secant is the same type thing. I graph cosine. Okay, the zeros are going to be my asymptotes, so now my zeros are at the pi over 2's. That's where the zeros are, right? At all the odd pi over 2's. And then I'm going to flip the parabolas up. So cosine, or secant, a little bit different because see how it kind of straddles the y-axis there? Okay, the first parabola is right on 0, 1. Okay, we'll come back to this. Please come to part 2.